Okay. Hi, everybody. My name is Manuel Sopena Ballesteros. I'm a system engineer of CSCS. And thank you for making the time to come to this talk. And I'm going to try my best to explain to you the current situation of OCHAMI at CSCS. So first of all, I'm going to give you an introduction of CSCS, what it is, how we work, very high-level overview. Before that, this is not a technical talk. I'm just going to explain roughly how we operate the system from the management plane perspective and the problems that we are aware of today of making the changes that we want to make. So I will introduce CSCS, how we work, then I'm going to roughly talk about what a management plane is from our point of view. Then I'm going to be a little bit deeper explaining the difference between CSM and OCHAMI. Then the challenge of introducing OCHAMI at CSCS, and then the plan that we have today to tackle this. So CSCS is an organization, it's part of ETH, currently have offices in Lugano and Zurich, and among all the things we do is we run a data center. We have different machines, and our flagship machine is Alps. And our goal is to operate high-performance computing for the elite of the research in Switzerland. Well, for everybody, but we try to encourage good work there. Now, within CSCS, we are divided or organized as many other organizations. We are divided in teams. Internally, we call working structures, and we have different types of them. Some of them manage the infrastructure of the system, others the facility, others take care about the, well, it's not showing. It's back. Okay. Others takes care about the life cycle of the compute nodes, others after the libraries to install, scientific libraries, security, IAM, etc., etc., etc. So we have a lot of teams, and most likely we are tightly interconnected in order to operate the system or the center. Okay, so now I'm going to try to give you a high-level overview of the tech stack that we run on the center. So basically we have two types of tenants. We have hard tenant and soft tenant. On this example, you see a hard tenant, what it is. So basically, you might think of the interface of divided on two layers. The bottom layer is managed by the management plane of Alps, and the top layer is managed by a different type of orchestrator. On top of that, you have some sort of automation which will coordinate all the different parts of the infrastructure, and the result is to have your cluster configured the way you want it to be. So if we go to the life cycle of a node, again from the high-level perspective, the machine boots, it goes to the network, it gets an image, it boots with the image, the operating system gets ready. We continue the configuration during runtime. Eventually, we install what we call HashiCorp Nomad, and then from that point in time, from the management plane perspective, the compute node is ready, and then the second part of the automation kicks in, which starts submitting jobs into the Nomad cluster. For the people who haven't heard about HashiCorp Nomad, is a tool from HashiCorp. They are the same people behind Terraform. And to put it simply, is an agent that you install on your compute node. It has a HTTP interface, and you interact with it in order to submit jobs. At the end of you submit the job, the Nomad schedules the job to the right machine, and then it runs. The end result is to have your machine configured. Most of the workload of the configuration of any compute node at CSCS works this way. The base image is very thin. The configuration also is very small. It's basically install Nomad some other basic things. And then on top of Nomad, we deploy what we call vServices, which are kind of packages of recipes of scripts that Nomad runs, and then at the end of the day, we have vServices to configure the storage, vServices to configure the network, vServices to install and configure Slarm. container engine, etc., etc. What I'm trying to say is here you have a high-level entity which coordinates the life cycle of the machine. Some of those operations will go through the management plane of the system, another goes through different type of automation. So different teams get involved here with different expertise, etc. Next, we have the soft tenant. This is much more simple from the tech stack perspective. This is more focused on external people that wants to use Alps infrastructure. When I mean external people, I mean sysadmin from other centers that they might come to us and then say, hey, we want to run a HPC system, but we don't have capacity, or we want to use your hardware. Could you please allocate part of your system to us? This is another option. So here, most of the life cycle of the node is managed by the management plane, and when the management plane finishes, at the end, the last part of the configuration is not about configuring Nomad, but how to impersonate the compute node. So the new tenant can take over, like changing IPs, SSH keys, etc. So the new tenant can come over and then continue the configuration of the cluster. So, okay, so hopefully you have an idea about how we operate, the teams, how intercorrelated we are, the different ways we have to deploy the system, different flavors, and now the challenge that we have. So, the biggest challenge we have on Alps is we want Alps to have as many different type of hardware as we possibly can. This does not only mean GPU or CPU nodes or etc. We also want to be able to be multi-vendor. Geo-distribution, at the moment, when I say about Alps, I can refer to things. On one side, we have different systems. We have 5, 3 of them in Locarno, the other 2 are geographically in other places. And also the biggest system out of those 5 is also called Alps, and that is in Lugano. We also want to do, well, the problem with geo-distribution is that this implies that it multiplies the number of management planes that you need to talk at any specific point in time. Depending on the system you're targeting, you need to change to talk to a different interface, and for that, having 5 systems might be okay, but if you have a large number of systems, you open the possibility of human errors or be able to, I don't know, power off a machine when they are connected to the wrong management plane, etc. Multi-tenancy without virtualization, that's also another of our goals. Because we are trying to be as much close to HPC as we can. What we do in terms of multi-tenancy is we isolate part of the machine to other use cases. So a tenant is someone, it might be from CSCS or might be external, who has a specific use case, and we isolated part of the machine to them. When I mean the machine is, when you say Alps, we have a few thousand nodes, we can allocate, I don't know, 500, 1,000, whatever, to a specific use case, and then we basically isolated them from the network, and we give them access to one of the flavors explained before to the end user. And the end user here is a sysadmin. And that opens the challenge of different workloads that we need to support. Some of these workloads are based on traditional HPC systems, like Slurm clusters, while others are more targeting Kubernetes. And then on top of that, it's up to the user what they want to support, what they want to run. Okay, so now we're going to the management plane side. So a management plane for us is a tool. It's a tool that we use in order to manage the compute side of the system and to be able to do what we want to do with it. Build images, configuring the boot parameters, power management, access to the console. We want to check hardware errors, troubleshooting, etc. So the current management plane that we use is CSM. CSM is provided by HP, or was provided by Cray, but now it's HP. This is because all the Alps systems are based on a HP Cray EX machine. So it's an appliance, you buy the hardware and you also get the software, and this software in particular is CSM. We have been using CSM since 2021, if I'm not mistaken. It has a lot of features. It's based on a microservice architecture. It gives you cloudish interfaces, so you can interact with it with, they provide a CLI, but different components have a HTTP interface, and you can use them independently with any client that you want to use. And then it's also based on Kubernetes. These microservices, some of them are standalone applications, others are basically Kubernetes controllers. So you cannot use the full system outside Kubernetes. Features of CSM, you have the list there, you have a lot of stuff. Identity Access Manager, software attestation, pipelines to build images, pipeline to manage the life cycle of the runtime configuration of the machine, diagnostics. It gives you templates to deploy your own workload manager. You can choose PBS or SLARM, you name it, power management, power capping. Data-defined clusters in a way in which you have a template or a schema, you fill up with the data, you submit it to the management plane, and it will do its magic, and at the end of the day, it will reboot machine, build images, change boot parameters to the ones you specify, etc. And it's hands-off. It's like autopilot. Monitoring, alerting, it has a lot of stuff. But what are the challenges? The challenges is the system is quite complex. The management plane is highly tight or coupled to the compute plane. That means that there are components of the management plane that if they have problems, they might compromise your compute plane. And that's a problem. It's a big problem. Also, project continuity. CSM already has an expiration date. The latest version is version 1.7. There won't be 1.8, so we won't have new features involved. Yeah, that's we have to stick with the dates from the vendor. And also it's vendor locked. You try to run a machine, a hardware that is not from Cray HP with this system, and basically good luck. Now, OCHAMI. OCHAMI is a tool, it's another management plane. It's part of the Linux Foundation under the HPSF umbrella. The members are CSCS, Los Alamos National Laboratory, NERSC, Bristol, HP, Dell. Is also, well, OCHAMI is a fork of CSM, so it's also microservices, it's also Golang, it's community-driven, also cloud interfaces, but it's tried to be vendor neutral, okay? So the theory here is you should be able to use OCHAMI with other hardware apart of HP. That's the plan. It's composable. OCHAMI will give you a battery of tools or applications. It's up to you what you want to use. You want to use all of them or only half or two or one. It's based on CSM, as I mentioned before. Its purpose is to be simple because it has less things. It does, it doesn't want to be as much complicated as CSM. And it's opinionated on how you install it. You can run it on Kubernetes or anywhere. What they give you is the source code and the binaries. It's up to you how you want to run it. Now, OCHAMI features, as you see, the list is far smaller than the one from CSM. I'm not going to go in there. The only thing is that on CSM, runtime configuration is based on cloud init-ish for the management plane and Ansible for the compute plane. On OCHAMI, everything is cloud init. And then the feature with the asterisk, I will explain later. Why is that? Why CSCS is interested in OCHAMI? Basically because we would like to own this part of our infrastructure. We would like to get involved into the development. Being an open community, it helps. Have members that share the same field as we do as HPC data centers also helps in order to align of getting objectives, define objectives. And it's easy to adopt for us because we already have experience on CSM. We have a lot of engineers who know CSM very well. So introducing OCHAMI it will help us to understand the foundation of this project. Okay, so now we will go with the challenge. So ALPS has multiple communities. As I mentioned before, we have different types of tenants. Each tenant, in this case, is managed by a different sysadmin. They look after the users, they decide how to use the infrastructure, and they operate through the management plane. Now, if we introduce OpenChami, we're going to introduce a change there. There are many people involved, different groups, a lot of questions, and that's going to be a little bit of a problem for us to tackle all this. So our approach here is to tackle one tenant at a time. We will start with CSCS, which is the biggest tenant. We are part of the same organization. The communication should be easy. We are very familiar with our use cases. And it's also the most complicated one. So we think if we are able to achieve all the requirements, if we are able to do a smooth transition from CSM to OpenChami for our CSCS colleagues, we will have most of the work done for the rest of the tenants. We need to understand the feature from CSM and OpenChami, cross-match features, try to understand what is missing, and adopt our workloads to OpenChami. Here, I think you can read it. Okay, so here I listed a list of features that, in my opinion, any modern sysadmin will need to do basic operations of the infrastructure. On one column, you have what is supported by CSM, and the other one, what is supported by or provided by OpenChami. Now, if you remember on the slide of the features of OpenChami, I had a few items with asterisks, and here you could see the same. So, as of today, OpenChami is trying to be vendor neutral. But the reality is, like, for example, one of the things you rely on the vendor is the Redfish interface. And the challenge there is the Redfish is a vague specification in which each vendor has the freedom to do its own implementation. So that means you have a Redfish client for one vendor, one version of the Redfish, and you have no guarantee that this is going to work for another vendor. Actually, I have a story here. Last year, end of last year, we purchased some new machines for our OpenChami test environment. And one of the things we did is we went to multiple vendors. We gave them one tool from OpenChami called Magellan, which will scan the network, try to find Redfish interfaces, query them, and then give you the hardware inventory. None of the vendors were able to give us a JSON that was acceptable for us. So that means that there is some work there to be done in order to integrate vendors on the Redfish clients. And then the thing with the two stars are things that OpenChami does not provide today, but the community is heavily working on it. Yeah. Now, that's the challenge. Now, what is the plan today that we want to follow in order to integrate OpenChami on our systems? So, we want to do a smooth transition. That means we don't want to shut down the machine with CSM, install OpenChami, and then boot it, and then cross fingers and see what happens. We think that's very likely going to fail. So instead, what we want to do is to introduce OpenChami into a CSM system, installing it, connecting it to the same networks, and then be able to switch compute nodes from CSM to OpenChami and vice versa. Now, this is challenging. Honestly, as of today, we don't know if we are going to be able to achieve this, but we're going to try. We have for the next 3 months to try this. We know that, for example, Los Alamos tried this and they couldn't do it. We're going to try again, and we're going to provide feedback to the community. Because if we can do this, then we should be able to migrate clusters, group of nodes from CSM to OpenChami without having to migrate everything at once. And that's going to help us a lot because we will be able to start with clusters that are test clusters. If the process goes wrong, we can switch back, move it back to CSM, keep investigating about how to improve the situation, and then move them back to OCHAMI, and gradually start migrating more and more clusters. Eventually, we will run the production clusters, and then all these clusters will be the ones managed by CSCS, and once we're comfortable with this, we will start moving other tenants that are from outside CSCS. That's going to simplify the communication, the amount of work we have to do, etc. Once we are successful with that, then we have to spin up, well, we are already doing that actually, spinning up a few OCHAMI test clusters for our colleagues, other working structures, because we want to, there is a lot of work. One is to migrate the compute nodes from one management plane to another, and then, as I mentioned before, you need to do all the extra layers of automation that sits on top of the management plane. They also need to be adapted. So to be faster, we are already creating test environments to OCHAMI and giving to some other working structures so they can start exploring this tool. Once we have that, then the next step will be automation. One key point here is an open community. We don't want to be the reference of how to run OCHAMI or which version to run. CSCS, there are a lot of people. There are very impatient who are always testing new things. And what we want to do is to have a battery, well, not a battery, an automation process to redeploy different versions of existing components, or adding or removing components to the ones we're already working on with. And a key component here is the tests. The goal of the test is to make sure that any change we introduce will not break anything that was working before. And that's very important in order for us to have a good relationship with the rest of our colleagues. We're going to collect, OCHAMI has multiple projects, each one has different versions, so at one point we're going to decide which components to start with, and we're going to pick up the versions to run. We're going to create a package with that, and we're going to call it CSCS OCHAMI version XYZ. And yeah, we need to coordinate with many other people to get this work done. And another challenge of this is, for example, once you move one compute node from CSM to OCHAMI, what are you going to do with the monitoring? The monitoring might start screaming, saying that the node is down, etc. So we don't want that, because monitoring is critical for us. We don't want to have false positives there. Well, I can skip this. This is just saying that timing, because we need to coordinate with many different teams. So having early on conversations and timing, good timing, so people have time to coordinate themselves and coordinate with us, is very important. And then here I want to say, so what is missing? For example, I mentioned before a fleet manager. I mentioned before that in the future we will have a lot of instances of different management planes, and this is maybe a problem for sysadmins. It might introduce human errors or people doing operations on the wrong place, etc. So it will be a good idea to have like a fleet manager, something that will give you a high-level overview of all the systems there and will simplify the operations of what you want to do. Image inventory, OCHAMI doesn't have such thing. It has a tool to build images, but then there is no way for you to know who created the image, when the image was created, and what is in the image. This is something that it exists on CSM, but it doesn't exist on OCHAMI. So I think that will be useful, especially for security perspective. Sometimes you want to audit the image, you want to know, or maybe the image doesn't work, so you want to know who built it and ask that person directly. Redfish integration, I already explained this. This is, the problem here is that you need involved from the vendors, because if you want OCHAMI to be adopted by other people, you need to make it easy to use. You need to make sure that you are transparent, that the feature that you provide works. And again, we cannot build Redfish clients for all the different vendors, for all the different hardware that they provide. So the help there is crucial. And for that, the vendor, it's a chicken and egg problem because the vendor might wait OpenChami to have enough traction for them to invest. At the moment, HP and Dell are part of it. I think those are two major players. And yeah, we will see how it goes. Also, you have to think like you have an OpenChami cluster and then suddenly you add more hardware from a different vendor. What are you going to do? Are you going to recompile everything with the new clients, or you want to do this Redfish client as a plug-and-play thing, a plug-in thing, etc.? We have an RFD there. Currently, we are discussing these things. Image build pipeline, I think I already commented on this, and the cluster node configuration automation is also, there are a lot of tools and you need to use the tools individually. It would be good to have like a schema where you say, these are my build parameters, this is the group of nodes I want to interact with, build the image with this configuration, and then just make the magic happen. This also will help in order to do rollback. If you have a place where you can store this information, you make changes on the cluster, something breaks, because you have the history, you can roll back with the previous settings. That's it, that's pretty much it. I share with you all the links there of everything that I talked to in case you want to dig in. And happy to take questions.
Thank you, Manuel. We have one question here.
Thank you for the nice talk. So can you go back to the slide 11?
11?
Yeah, 11. So I think this is mostly related to CSM, but assuming that the feature is, most of the features are going to be implemented in the OCHAMI in the future. So I was mostly wondering the software attestation at the bottom. So can you give me some examples of the software here?
No, because software attestation is in a very early stage. Let me check. I have it here. So yeah, so you see. No, it's the next one. Yeah. So software attestation is the fourth one from the bottom, 2 asterisks under development. So at the moment, it's only an RFD and they are discussing about how to do that. They don't know, I don't think they are going to use the same model of CSM. CSM use SPIFFE, Spire, SPIFFE. I think they're going to use something different, but I cannot give you more details. You can ask me later and then I can send you the link to the RFD. Probably will have more information than what I can give you now.
One question from my side, did you consider to use any other deployment tool, or what was the decision to use OpenChami?
So the decision was because of the members of OpenChami are people who share the same, I don't know if the same values, but we work in the same use case. We are HPC centers. So it should be reasonably easy for us to align into a roadmap. Also, it's a fork of CSM. We know CSM very well, so it's going to be easier to introduce OpenChami to our engineers. The learning curve should be more flat because, again, we have been exposed to CSM since 2021. Yeah, pretty much it, because it basically takes a system that we already have, continue it instead of starting from scratch. The community should be aligned to what we want. And we're also familiar with the vendors. We are used to work with HP. Now, Dell for CSCS is something new, but we want to encourage other vendors to talk to us because we want to be able to work with more different type of hardware.
Okay, thank you.
Okay, thank you, Manuel.
Thank you.